Hello everyone. So in this video we are continuing the previous lab number 2, and we will now perform the Norton circuit. So previously we performed Thevenin circuit, in which we find the V Thevenin and use R Thevenin in series. So in Norton we actually have current I Norton and R Norton in parallel to the current. So first let's set up this circuit um, in which we will set up our current source. So we have this small IC. Let's place it in the breadboard, and we need two resistors. So um, one of them is 20 kilo ohms and the other one is 24 ohms. So the one connected at the center, pin number 2, is 24 ohms, and the color code is red, yellow, black. So we will simply connect this one at the center like this, and the second resistor is red, black, orange. We will connect it to the third port, and we'll make sure that we keep enough gap so that they don't start to touch here and get shorted. Alright, next we need to connect jumpers. We will connect this to V plus and to the N pin, the first pin of the board, like this. And we will connect our multimeter in series. We will change the knob to milliamps and press function button so that we are on DC. Alright, now we will connect one lid of our multimeter like this to the I out, which is this port here, and we will connect the black one to V minus, like this. Here is the V minus pin. Our analog discovery 2. Now we will go to the waveform software. So in the waveform software, we will first set our supplies to +5 and -5. So the second one will be -5. We will turn on the master and we will note down the current. So it should be around 8.3, which is what we are getting here. Alright, which means that our current source is now set. So at this point we are getting 8.2 milliamps. Now the next part is that we need to set up our Norton circuit. We will use 470 ohms and we will build up this circuit here. We now have the I Norton ready. We need to connect 470 ohms in parallel. So one thing, that if you see that I have connected my black one to V minus, if I connect it to ground, you should get the same result. Let's do this. So now I've connected to ground. So if I'm connecting it to ground, there is no need to use V minus in this case. It's fine, because even in this figure you see that the circuit is connected to ground. If you're using V minus, then you need to make sure that your lower end is V minus, like 470 will be connected to I out here and then V minus. But let's keep the things easy and we will connect this to ground. So let's grab 470 ohms resistor. So 470 ohms resistor should be this one. We can always check it using our DMM. Let's do that. Yes, so this one is 470 ohms. Let's change it back to milliamp and DC settings. Alright, so since in the circuit we need to measure I load, let's first connect 470 ohms. So 470 ohms will be connected to I out like this, and then it will be connected somewhere here. We will connect that point to ground. Let's grab jumper pin here and then ground on our board. Alright, the next thing is that we need to connect our resistor, our load. So first we will be doing that with 100 ohms. So since we need to measure the current, what we will do is that we will connect our DMM, our ammeter here like this, and now this is the other end where we'll be connecting our load. So this is a 100 ohms resistor. One end should go to ground and the other end will be receiving current through our multimeter. So let's connect this to ground, and we can connect at the lid anywhere, and then I will just connect up my DMM black lead. So we get 6.72 milliamps in this case. And to confirm, you can also use these simulations provided. You can change the value of resistor and see what should be the current and what should be the voltage. Now to measure the voltage, we need to simply add our cables that will connect to the board. Let's do that. So we need to connect 1 plus to the positive side. Let's grab a bigger cable. So 1 plus to the positive side like this, and 1 minus to the negative side. So 1 minus to the ground, not negative side in this case, just ground. So I've connected it. Now we can go to waveform and see what's the voltage. It's 666. So again, as we saw in the simulation, 400 ohms. Supply and see. So it should be 6.75 and 674 millivolts. So current is good, and of course voltage is also good. You will change the resistors and check it for different values. So this is how you will perform your Norton um, experiments, Norton circuits. Finally, you will observe Thevenin Norton equivalency in 2.4.4. These are just calculations. And in 2.5 you will observe maximum power transfer. Just read it and you will see that when the resistor is equal to the load is equal to the supply resistance. So in case R Norton, when your load resistance equals your um, Norton resistance, then you will have maximum power transfer across your load. So you can read further on this. You go to the following article and you can read this article to understand more. Yes, and finally you will be doing some post-lab calculations, and if you have any questions you can definitely just send us an email and we will help you out in this lab. Thank you so much for watching the video.